Hi guys, welcome to Unit 10, Lesson 3 Notes, the second part, Simplifying Radical Expressions. By the end of the day, you will be able to use conjugates to simplify radical expressions. Now you'll remember from yesterday that there are three things we need to check to see if a radical expression is simplified. Remember, a radical expression is something under a radical, the square root. So first we need to check that no radicands have perfect square factors. We don't want any perfect squares underneath our radical. So in order to do this, we check the prime factorization of the radicand. We split it up into its factors and then take all the squares outside of our radical. Second, no radicands can have fractions inside. We'll split up our fractions. So if you have the square root of a of b, we'll split that up into the square root of a over the square root of b. And finally, no radicals can be in the denominator of a fraction. If you have radicals in the denominator of your fraction, you need to do a process which is called rationalizing the denominator. So you will need to rationalize the denominator. That will get rid of the they'll give the radical in the denominator. In order to do that, we're going to do something today called conjugating. Now, if you're in my Spanish class, conjugate is a way that you change the verb to match the subject. That's not what we're doing. We're doing something completely different today. So all binomials have what is called a conjugate. And a conjugate looks like this. If you have a plus b, then the conjugate of a plus b is a minus b. And if you have a minus b, the conjugate of a minus b is a plus b. That's it. That's really all conjugate is. So for example, if you have the conjugate of a plus 2, its conjugate is a minus 2. If you have the conjugate of of 5 minus b to the third power, that's 5 plus b to the third power. What are you noticing, guys? Please notice with your conjugate, the only thing that you do is you flip the sign. The plus becomes a minus, or minus becomes a plus. So in number 4, our plus became a minus. In 5, our minus became a plus. That's all you're going to do. So to make a conjugate, just flip the sign. Change the plus to a minus. So here in number 6, we have c plus the square root of 7. What is its conjugate? Oh, that's c minus the square root of 7. Yay. And what's the conjugate of 8 minus the square root of 23? Well, that's 8 plus the square root of 23. Now, that's great, but why? Why do we need this? Well, we're going to use it to help simplify radical expressions. We're going to do that by calling on the difference of squares. Remember when you have the difference of squares, that's when you have something plus something times something minus that same thing. That's equal to a shortcut. There's a shortcut to expand this guy out. We don't have to FOIL him. Instead, we know that is just a squared minus b squared. Again, if you have some number a plus b and then a minus b, that's a squared minus b squared. So if the numbers are the same, you have a and b, then you're going to keep a and b, but they're the difference of squares. So we'll follow the pattern of whatever a is squared minus whatever b is squared. That's why it's called a difference of squares, because difference means minus and squares is the square. See, you've got a difference of squares. So what I'm going to do is I'm going to put my difference of squares here, and I'll follow that pattern for each of these problems. Okay, so here we've got 3 plus the square root of 5 times 3 minus the square root of 5. Notice these are each other's conjugates. 3 plus square root of 5, 3 minus square root of 5. And using our difference of squares, that's going to be 3 squared minus the square root of 5 squared. And what's 3 squared? Well, that's 9. What's the square root of 5 squared? Well, the square roots, the square and the square root cancel out. So 5. So 9 minus 5 is 4. Wait, hold up. You're trying to tell me that this whole thing, that's just equal to 4? Yes, that is literally exactly what I am saying. Isn't that so nice? Ugh. And that's why we like difference of squares, because it cleans it up. And that's why conjugates are important, because it will help clean up an expression. Let's do our next one. So here we have the square root of 6 plus the square root of 5, square root of 6 minus 5 times the square root of 6 plus 5. Because these are conjugates, we can plug those into our difference of squares formula. That's square root of 6 squared minus 5 squared. The square root of 6 squared is just 6, and then 5 squared is 25. 6 minus 25 gives us negative 19. Go ahead and follow this pattern and see if you can do numbers 10 and 11 by yourself. Hit pause and see how well you do. So number 10, our first term, our A term here is 4, and our B term here is the square root of 3. So we're going to plug those into our pattern. We get 4 squared minus the square root of 3 squared. 4 squared is 16. Square root of 3 squared is 3. That's equal to 13. And finally, here, following our pattern, we will end up getting 3 squared minus the square root of 2 squared. 3 squared is 9. Square root of 2 squared is 2. And we get 7. Yay! That's so nice. Now notice that we started out with a bunch of kind of gross expressions. We had radicals in here, we had pluses, we had minuses, but they all came out to rational numbers. In fact, these are all integers. That's nice. That won't always happen. But conjugates are useful for simplifying radical expressions. Remember radical, square root symbol, because their product will always be a rational number. We're going to use this fact to help us rationalize the denominator. So here in our activity 3, you'll notice that our denominators are not rational. Yikes, it's got a square root in it, and we want to clean that up. So what we're going to do is we are going to multiply by its conjugate. If I want to simplify this, I will multiply by the conjugate, because I want to clean up this 3 minus the square root of 2. What is the conjugate of 3 minus the square root of 2? Good job. It's 3 plus the square root of 2. Now, I can't just multiply this expression by 3 plus the square root of 2, because that will change its value. However, what won't change this value is if I multiply by 1. So I'll multiply top and bottom by the conjugate. This is because the conjugate divided by itself is 1, and 1 doesn't change it. So to rationalize the denominator, let's add this way at the top. To rationalize the denominator, you need to multiply top and bottom by the conjugate. So let's go ahead and do that now. We're going to distribute 6 to both terms. of our conjugate. And then here we have our difference of squares already because we're multiplying a binomial by its conjugate. So that's going to follow our pattern. We will have 3 squared minus square root of 2 squared. Now that's equal, here I'll move this guy over so we can see him. Now we can distribute our 6 to both terms. We get 6 times 3 is 18, plus 6 times the square root of 2, all over 3 squared is 9, square root of 2 squared is 2, and that gives us 18 plus 6 times the square root of 2 all over 7. Now this fraction cannot be simplified, so that's it, that's what we get. Great? Great. Now I know that this might not look any more simple than this to you, but we do not like radicals in the denominator. So the reason it's simpler is because we moved the radical out of the denominator and put them up top here in the numerator. Think you got it? Go ahead and try number 14. So number 14, we see that we have this radical symbol in the denominator, and we do not like that. So to get rid of the radical symbol, we are going to multiply by its conjugate. So you have 8 minus the square root of 5. Now again, we need to multiply top and bottom by the conjugate. So let's distribute that 3 into both terms. Will give us 3 times both 8 minus the square root of 5. And then on bottom, because we're multiplying by its conjugate, we can use our difference of squares shortcut. That'll give us 8 squared minus the square root of 5 squared. So let's go ahead and distribute our 3 into both terms. Purple. This will give us 3 times 8 minus 3 times the square root of 5, all over 8 squared is 64, minus the square root of 5 squared is 5. We can clean this up because 3 times 8 is 24, 3 rad 5 stays the same, and then 64 minus 5 is 59. And there it is, all cleaned up. Now we're going to take everything we've learned and put it all into practice using some variables, because sometimes we'll be dealing with numbers and we don't know how much they're worth. So we'll have to plug some variables in. Now this is going to call on what we did yesterday as well. So here we have a bunch of numbers all here under our radical symbol. So we're going to split them up into squares and see what we're going to factor this guy, and then we're going to see what we can do with him. So we have our square root of 25 is equal to 5 squared. A squared is already written as something squared, so that's nice. B, cool. And then c to the 4th power is the same thing as c squared squared. We're going to use our properties of exponents to write c to the 4th power as a square. Great. Now that we have several things that are written as squares, we can take their square roots separately. So that's equal to the square root of 5 squared times the square root of a squared times the square root of b times the square root of c squared squared. Now 3 of these square roots are going to work out real nice because they have a square. They have a square and they have a square underneath the radicals. So those are going to cancel out. So that gives us 5 times a times c squared times the square root of b. Now I'm going to move this c squared out front because that'll clean it up. And then we'll be done. So this whole thing is equal to 5a c squared times the square root of b. So again, our process was we looked at our radicand and we factored it. We figured out how we can write all of its factors separately. And I expressed them as squares because the squares will cancel out with the radicals until they don't, and then you have to leave that under the radical symbol. Then we cleaned it up and we are all set to go. Let's do our last one and then you can get started on your homework. So here again, we're going to split everything into its factors. So I'm going to split 24 into 4 times 6, x cubed into x squared times x. Then y squared I'll keep the same, and z I will keep the same. Again, 24 I split up into 4 times 6. X cubed became x squared times x, and then the other two remained the same. Now why did I do that? I split them up because I want to be able to write its factors as squares. I want to be able to pull the perfect squares out of our radicand. So 4 is 2 squared. 6 doesn't have any square factors. X squared is x squared. Y squared is y squared, and z. Awesome. Now I'm going to take all of my squares, and those are going to cancel out with my radical symbol. Oh, I got one step ahead. Because these are all factors, I can write them as their own square roots. So that's the square root of 2 squared, square root of 6, square root of x squared, square root of x, square root of y squared, square root of z. Now each of these squares cancel out with their radical. So that gives us the square root of 2 squared is 2. Square root of 6, square root of x squared is x. And you have square root of x, square root of y squared is y. You have square root of z. Now let's combine everything not under a radical. That gives us 2 times x times y all together. And then all the leftovers go back under the radical symbol, 6xz. That's it. We simplified that radical. So again, with this one, we took our radicand and we factored it. We factored all of the squares out of our radicand. And then we took all of our squares, we took their square roots, and that got them out from under our radical symbol. And then we cleaned it all up. So remember, to simplify a radical, 3 things have to occur. First, check that the radicand, what is under your radical symbol, doesn't have any perfect squares underneath it. To do that, you need to prime factor it and take all your squares out. Second, make sure that you don't have any fractions in there. We worked on that yesterday. And third, you don't have any radicals in your denominator. We worked on rationalizing the denominator today, and to do that we multiplied by the conjugate of the denominator. I hope you enjoy your homework.